We're going to go ahead and get going. It is 8:26. It is, we're running a little behind here because of the weather and story. We're running a little behind because of the weather. So class started late. Let the record show that we have about half the class. I think there was some confusion as well as to whether or not this was because of the snow day yesterday, that this was a Friday schedule or a Thursday schedule. So it is indeed a Friday schedule. So that's kind of what we're going to do. So right now what we're going to do is we're going to review what you guys came up with your map assignment. So we were working on sectionals, and what we were doing is that we were doing what? Somebody give me a hand. What? Kylie, what were we doing?
Kind of planning for cross country. We were determining the distance between each airport and the true and magnetic courses for that.
Okay, so we have, first of all, we have, the first thing we do is what?
General direction of flight.
Oh no,
we measure our
compare.
We measure the scale with the scale on the plotter.
The first thing that you do before every one of these problems is check your measuring device against the scale on the map. That's the first thing you do. Can I use this or not? Is this more than just a straight edge and something that I can use to determine my true course? Okay, so that's the first thing that we do. Second thing, we need to identify the airport. Two-finger method, from to, or from to. And the very first thing that you do before you move those fingers is what?
your general direction.
Determine your GDOF, general direction of flight. What general direction am I flying? Then you're going to write down what?
The general direction and the degrees.
A corresponding general heading to that direction. It can just be rough, but it'll be close. You can tell if it's north, south, east, west, northwest, you can get close. And the reason that we do that is because the protractor that we're going to be using to measure our true course is going to offer 4 numbers. And based on our general direction of flight, that is going to dictate which number we choose to say, does this make sense? For instance, if you're going to be flying from here to there and you determine that there is west, and you come up with a number that's 090, you know you're flying the wrong direction, right? Because you should look for 270. Make sense? So, general direction of flight and then a general heading that corresponds to that direction. Then you draw your line. How do we draw our line?
We put the pencil.
Pencil, the center of the airport. Slide the plotter beside it. Rotate the plotter around against the pencil until you're at what?
In the middle of each airport.
The center of the other airport, and then firmly holding the plotter, we draw our line. Solid enough to read it, but then enough where you can erase it. So that's kind of what we're trying to do. After you draw your line, you do what? Get your distance. Get your distance. While you have your plotter on that line, get your distance. You may not need it for the problem, but it's good to do. Since you're right there, be efficient. Okay? After you have the line drawn, now then you're going to determine what?
Your true course.
True course. Remember the formula. True course equals blah. Then after you get your true course, by the way, how do you do that?
You take this, you find a line of latitude or longitude, and you put it in your center thing.
You'd align it with the line that you just drew.
So we use the top edge now, not the bottom. We use the top edge. We slide the top edge along the line that we have drawn until our grommet is on a line of either longitude or latitude. In some cases, the angle may be such that you have to slide your plotter a little further along to find something that's going to give you meaningful information. Because in some cases, especially if you're using the inner 2 arcs of your protractor, you may need to find another angle to give you what you need. So just be aware of that. Once you have that, then you look, where does that line of longitude or latitude intersect the top arc, whatever, of your plotter. Then you look at your numbers. One thing that you notice is that when you look at those numbers, they go the opposite direction that you kind of might think they're going to go. So you have to be careful about that. So you look at your number. Then you determine, is this the right number? Nope, that's the opposite direction. Then you look at the next arc. Is that the right direction? Maybe, maybe not. So that's kind of what we do. So then we would determine our true course. From that, we do what?
We would find the closest line of magnetic variation.
Okay.
And then we would subtract, like say it was
Well,
9.
if it was east, we would
If it
subtract.
was east, we would subtract. And if it was west, then we would add because east is least and west is best.
Okay, very good.
And then
So what we do is that we look for our plus or minus magnetic variation. That is the isogonic line that is the closest to our course that we either fly over or that is closest to our general direction of flight. And then we round up so that we do a full degree. We can't really fly a half degree on purpose. So we pick, do we round up, do we round down? And then you determine, do I add it or subtract it? The thing that we always know here in Colorado is that we're always going to subtract. If we're on the East Coast, however, we're always going to add. And then along the way, somewhere in between, that kind of changes. Somewhere between New Orleans and somewhere in the upper reaches of North Dakota. Okay, because that is the agonic line. The agonic line is going to be 0. That is where the magnetic compass and your magnetic course will be the same. But remember, the lines of magnetic variation are called isogonic lines, right? Okay, we determine that, and then from that we get our magnetic course. Okay, so that's what we've got to get our magnetic course. Your assignment was to look at these airports and determine your magnetic course and your distance. All right, so here we go. Let's start with the first one. I'm going to start here with table number 1. Ladies, what did you come up with here for KASE to KRIL?
Our general direction of flight was 315 degrees. I didn't write that. And then we got our true course was 294 degrees.
What was it?
294 degrees. 294 degrees.
Okay.
And then our magnetic variation was 10 degrees east.
Okay.
And then our magnetic course was 284 degrees.
Okay.
And our distance was 44 nautical miles.
Okay. Gentlemen, what'd you get? Gentlemen? Is that what you got?
I think we did this together.
We did this assignment. This is the one that we sort of did in class.
I think
So,
this was the one that you showed us on the big
Yeah,
map.
that was the one that we all did in class.
yes, it was. All right, so now I want to show you something here on ForeFlight. So on ForeFlight, what we can do is I can put in KASE and KRIL, and what it will do is that it'll draw a straight line for me. We can look at the flight planning function here, and we can look here at our nav log, and what it tells us is the thing that this doesn't do. It won't give you your true course, and it won't and it will ultimately give you your magnetic course. But what they do is they take the current wind conditions, and your magnetic course actually is with wind. So you can see here that you came up with a magnetic course of 284. This shows a magnetic course of 283. The mileage, however, is spot on, 44. Now, flying 44 miles, and let's say you're a degree off, how much is that going to affect you? Hardly any. Let's say you're 3 degrees off, 44 miles. You may not wind up quite where you think you're going to be. What about 5 degrees? Okay. Now what about 5 degrees over 150 miles?
Maybe not.
Especially if you're flying out over open water. because you may, depending on your altitude, you may not be able to see land. So that's going to be a thing that the reason that we want to be as precise as we can with these measurements. Okay? So let's take a look now at the next one. Let me get rid of this. Edit, clear, clear all. All right, what was our next one?
KRAL to direct to KCNY.
All right, magnetic course, what'd you get?
Magnetic course 235 west southwest.
235, magnetic course, what'd you get? 234, what'd you get? 235. What was your distance? 106. What'd you get? What was your distance? 112. 105. What'd you get? 106. We appear to be a little off here. KRIL to KCNY. So with this one, on our nav log, it tells us that with the wind, we have a 234 is going to be our magnetic course on this. Right now, the winds are kind of out of the southwest right now. And again, this is showing the winds aloft because I think mine are at 12,500 feet. But so with that, and the distance that we're showing here is 105. 105. So now, on all of these that you're going to correct, I want you to go back and figure out what happened. How did we get off on that? But not right now. Okay? All right, let's go to the next one. KCNY, KTEX. Diego, what'd you get? Magnetic course 112. Distance? 99. Gavin?
98 nautical miles, and the magnetic course of 108.
108. Okay, we're 4 degrees off there. God bless you. Ladies, what'd you get?
For magnetic course 109.
109. Distance? I'm going to ask you for your magnetic course and distance. That's what I'm going to be asking you.
98 nautical miles.
Okay, 98. So everybody got the distance about right, but we have some discrepancy here about the magnetic course. KCNY, whoops, nope, hang on. KCNY, KTEX. With that, we're showing here with the wind, we're showing 112, but that's with the wind. I would think without the wind right now, it would be closer to probably 108 or 109. So again, guys, if you're off on this, you need to go back and figure out what happened. How did we get off on this? All right? Let me just take another look here.
So, Mr. Ron,
Yes.
when you're planning a flight, would you use ForeFlight over one of these maps because it will give you a more accurate heading for the wind conditions?
Not necessarily.
You wouldn't?
No.
But what if
If you were doing a long flight, would you use that just
Yes.
against the wind?
Yes.
because
Here's the thing. Right now, when you guys are starting this, you're using maps.
yeah,
The next lesson is going to be on wind.
okay.
Okay? With that, you're going to figure it yourselves.
Okay.
Because again, unless you understand the it begins. Unless you understand the underlying principles involved in this, pushing buttons, if you're just willing to accept what a machine tells you, then woe unto you. I say again, whoa.
Now the
So, all right, so we have that. So KTEX. Now, let's get rid of that. And now we have what? KTEX 1 Victor 8. Ladies, what'd you get? And I want magnetic course and distance.
Magnetic course 87 degrees east, distance
087. Heading is a what?
Oh, 3 digit.
3-digit number. Go ahead. Gavin?
I got 90 nautical miles, it says 9 or 5.
0, 9, or 5?
0, 9, 5.
We are off here, guys. What'd you get, Diego? 9, 5? 0, 9, 5? Uh-huh. Okay, ladies, let's take a look at that. And again, it's going to be hard because I can't necessarily tell you exactly what the magnetic course is going to be on this without me actually measuring it, which I probably should have done. 1 Victor 8. So here's that with that wind, and it's showing a tailwind here of 089er is going to be your magnetic course. So guys, just double check that, make sure that's kind of where it is, and the distance there is 89 nautical miles. If you're going to round, always round up on your mileage. Be conservative with your fuel estimates.
Wait, so were we right on?
You said 087. I don't know.
Okay.
I don't
Oh,
know.
because of the wind.
Yeah, because of the wind, I'm not sure yet. Because I don't, what's that?
The 2 fingers, you can do like a little plotter from that.
Well, I can, but here's the problem.
It's not automatic.
When I do that here, is that right? Is that right with the wind? Hang on, let me go back.
It's not going to.
I was thinking that whenever I would do that with that, it would also give me the wind. Give me just a second. I have KTEX 1 Victor 8. Because didn't that say 89 or did that say 87?
I mean, 89.
It's at 8, yeah.
Yeah, it's 89, so that's 2 degrees off. So I think you're right, Gavin. I think that that 2-finger method thing, that's going to be our play
So
to do that. So with this, if I get rid of this, clear that, and I put this on here. So if I go from there to there. Oh no, that's wrong. That's not 1 Victor. Hang on. This one. See what I'm doing there? So that's going to be magnetic course of 087. 087. So you guys kicked it. You boys, fix it. Okay, and the distance there is 88. Yeah, 89 point nautical miles. Yeah, we'll go with 89. Okay, thank you, Gavin. I'd like to go back and look at that other. Well, shoot, we're almost out of time. Golly. Oh, darn it. All right, so what's our next one here? 1 Victor 8 KANK. What do we get, ladies?
magnetic course 351, and then our degrees north,
Tree 5-1,
and then our distance was 45 nautical miles.
45 NM. Have you guys noticed the way I pronounced 3 and 5? Have you noticed that? Tree and fife. I do that on purpose. Why do I do that?
To really enunciate difference.
I am modeling the actual pronunciation indicated in the Aeronautical Information Manual on how to pronounce the numbers. Tree, fife, niner. Everything else is kind of the way you might expect. Okay? So, 1 Victor 8 to KANK, tree 5-1, 45. Gavin, what'd you get?
46 nautical miles and course of 3-4.
Tree 4 tree, we're way off. Distance of 45, tree 4-4. Okay, you two are way off. Let's take a look at this. 1 Victor 8 to KANK. Check that out. Let's get rid of this. magnetic tree 5-2, 45 nautical miles. Tree 5-2. Now, boys, why are you guys off fully 10 degrees? What's that? How to do the north and the south thing? Okay. Let's do this real quick. All right. One of you bring your map up here to this center table and let's look at this real quick. And for those of you looking at home, I don't have a great way to tell you what to do. Let me see a plotter. Yeah, let me see a plotter. All right. So we have, where is K, A, and K? Is this 1 Victor 6 here?
Wait, no, it's over here.
1 Victor 6, is this K and K?
Yep.
Yes.
Okay, all right. So you can see that they have drawn a line here, right? Now,
We forgot to erase that.
see this here? So with this, we can slide this here, here, and we're going to slide, whoops, I want this, right? Does that look like it's on the bullseye?
Yeah, pretty close.
Okay, all right, so now I want to look here, and can I do it this way? I think I can.
I think you just have to go down to the third.
Stand by. I don't have my glasses on here right now, so does that look like it's on there?
Yep,
Right
yeah,
there?
it's good.
All right, so where do we measure it? Right here. This is where you measured it, clearly. So if you look right here, if I'm looking, hang on, let me get my glasses so I can look at this. Okay, that is right there on the crosshairs. Line that up, line that up, right on the crosshairs. So if I look at this right there, if I'm looking at that, what do you think? Okay, I'm going from here to here. What's my general direction of flight?
North.
North. What is going to be my general heading?
360 or
360 or 000, right? All right, so if I look at this, I mean it is right on the doggone line here as going which direction?
North.
North. So with that, I'm going to write down here 360. The reason I'm going to write 360 on this is because it's going north, and I can subtract from this because I know I'm going to subtract because I have what?
-9.
I've got it. I have 9 degrees east is my closest line to magnetic variation. 360 minus 9 is going to be what?
351.
351. So what did we get here?
351.
That looks like 352 right there, but there again, that's just going to be pretty close. So did you guys see how to do that? Okay.
Oh, we got some.
Yeah.
We got 351.
Yeah, I'm sorry. Here's your map back.
Thank you.
All right, good job, ladies.
The general direction of flight.
Well, that's part of it. Okay, we're going to have to bust through these. Doggone it. Guys, it's time to go. All right, for Monday, we're going to finish this up. Save these problems. Save these problems, because we're going to use these airports and your information. We're going to use them again. So save them. Oh, it's Tuesday, yeah, because you guys have the holiday off on Tuesday. Okay, okay, okay. Wow. All right. Oh boy. The snow day and the holiday kind of messed me up there. All right, so be prepared for a quiz on Friday. AFDs, or the actual, what they refer to as chart supplements. Have you guys kind of dove into these things and kind of boned up on what information is where you can find the answers to things, what different sections that there are in here and how to use them? This is going to be your friend, because on Friday we're going to have kind of a big quiz on Friday.
Is it on the maps too, or just?
Yes, it'll be on the maps as well. So it's going to be on the AFD, it's going to be on the maps. Okay? So Tuesday we're going to finish this review. What?
We're gonna do it.
Okay, well,
We'll figure it out.
yeah, okay. Guys, get out of here. Watch the videos. Tyler, I'm sorry, Cooper, get with Tyler, get with somebody. Get with somebody.
Yeah, I will.
The pace is going to be a lot faster.
Yep.
All right.
Thank you.
All right, guys. Enjoy your day. Have a great weekend.
I'll see you at 4.
Yes.